Welcome back. Today we're going to talk about applying properties to operations, namely just trying to find equivalent expressions based on provided information. For number one, for example, this isn't so much of a property, but what we are doing is we are taking all of these n's and condensing it because this takes too long. We have 1n plus 1n plus 1n plus 1n plus 1n plus 1n plus 1n. That is 1, 2, 3, 4, 5, 6, 7 n's all being added. Now normally when you do 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, you get 7. It is no different when you have n's. Instead of having just a regular 7, you now have 7 n's. And that would be our answer for number 1, 7n. Number 2 is an example of the distributive property. So what we are going to do is take the 5 outside of the parentheses, and no symbol next to parentheses means to multiply. So we will do 5 times 4 and 5 times 8c. 5 times 4 equals 20, and 5 times 8 would equal 40, with a c on the end, because 5 times 8c is still just going to be 40c. For number 3, we have, forgot to write my answer. For number 3, we have 80 plus 60w. Now, the goal whenever you are trying to use distributive property is to use a common factor and place it on the outside of your parentheses. Between 80 and 60, I happen to know that I can divide both of those numbers by 20. So I will put 20 outside of a set of parentheses. I am not getting rid of the w, so my w will still be in here. And then I simply do 80 divided by my common factor. 80 divided by 20 is going to equal 4. 60 divided by 20 is going to equal 3. And this is all I will do to try to find an equivalent expression. 20 times 4 plus 3w. Number 4 will be exactly the same thing. You need to find a common factor between 63 and 49. You need to find something that you can divide 49 and 63 by. For those two numbers, there is only one number you can divide them both by, which is 7. So 63 divided by 7 will equal 9, and 49m divided by 7 will equal 7m. We'll write our answer over here. And right here, I'm going to slide the page down, and I'm going to give you a chance to pause the video here so you can work on a few of the problems ahead and then unpause it when you are ready to go over it. If you didn't pause it, well, we're moving on anyhow. 63 and 36, those both have common factors of 9. If I remove the 9, 63f divided by 9 equals 7f. 36 divided by 9 equals 4. 6 operates backwards. We are going to redistribute my common factor into my brackets. 6 times 7e equals 42e, and 6 times 3 equals 18. Number 7, we are going to be combining like terms. We will be combining my a variables before combining my constants. 3a plus 2a will equal 5a, and 7 plus 8, or 8 plus 7, will equal 15. Number 8, the same as number 6, we will combine my constants and variables together. Variables with variables, constants with constants. 2j plus 8j will equal 10j, plus 6 plus 4, 10. Number 9, back to distributive property. We will distribute this 4 by doing 4 times 2h and 4 times 6. 4 times 2h equals 8h, plus 4 times 6, which is 24. Number 10, we use distributive property again. 4 times 4 is 16. 4 times 5b equals 20b. Number 11, distributive property again. 7 times 10 equals 70, plus 7 times 6g equals 42g. Number 12, they give us an incredibly easy problem, much like number 1. 1s plus 1s plus 1s. 3s. Number 13. I'm getting a bit lazy and not writing my answers over here. Just a bit redundant in this case. We have 1, 2, 3, 4, 5, 6, 7 u's all being added together. 7u. 14 and 15 will both use the distributive property. Number 14 is 5 times 7p. That is 35p. And 5 times 3, which is 15. Number 15 is 4 times 3, which is 12. And 4 times 7y, which is 28y. Number 16, we need a common factor between 35 and 15. Both 35 and 15 can be divided by 5, so we will use this as our common factor. We have 35k divided by 5. 35 divided by 5 should equal 7, so 35k divided by 5 will equal 7k. 15 divided by 5 will equal 3. That is it for number 16. 17 has the same issue, only it is not so obvious what to divide by. One is even, one is odd. For this problem, 35 and 56 are both a part of my 7 times tables. So we will divide both of those values by 7. 35 divided by 7 equals 5. And 56z divided by 7 is going to equal 8z. For number 18, we will be combining my variables and combining my constants. 8v plus 6v equals 14v, plus 5 plus 6, that is 11. Number 19, 32 and 28 both have common factors. We're going to say 4. We can divide both of those numbers by 4. $32r divided by 4 should equal 8r. And 28 divided by 4 should equal 7. Last but not least, the 20th problem has 1, 2, 3, 4, 5, 6, 7 t's that are all being added together to get 7t. That is all there is to using the distributive property, going back and forth from one type to the other, and by combining like terms, because I know we need a little bit of extra practice with that from time to time. Remember, you can only add together your same variables or your constants. You cannot combine a variable with a number that does not have a variable. And that is all there is for this particular practice assignment.